Hello, ladies and gentlemen. I am coming at you with just a quick one today after the last video was so long. This is graphing absolute value and graphing inequalities. I believe that much of this is going to be review for you, and it goes real quick. It's only one page. So first of all, the general form of an absolute value function. So you've seen this maybe. I don't think I teach it to 9th graders, but I think if you took this in 8th grade, you learned it in Algebra 1. So this is going to be y equals a absolute value of x minus h, close that absolute value, plus k. All right? And what this means for an absolute value graph is that hk, just like you keep seeing over and over, hk is the vertex. Because an absolute value graph is going to look like a V when you graph it, right? Absolute value means the distance away from a certain number. So as you go farther towards the positive numbers, you're getting further away from the number. And as you go farther towards the negative numbers, you're getting further away from that number. So it makes sense that we would make a V shape. We're getting further away from something on both sides. So if A, this A right here, is positive, then this sort of V shape opens up, just like you might remember from parabolas. And if A is negative, obviously, then our V shape will open down. Opens down. Some other things, actually one other thing that's important that you might not have touched on in another class is that the A value gives the slope of the line on both sides of the vertex. Typically, our A value is just going to be 1, but you have the ability to easily graph something with a slope that's not 1, because we know how to graph slope, and we can just plot our vertex and go from there. So here is an example. Y equals the absolute value of x minus 5 plus 2. It's possible that in other classes that you've taken of math so far, you might have just had to put this into a table of values and graph those values. Now we can just take the vertex. Notice that this vertex has a minus h and a plus k, so don't get your signs confused, because the vertex of this graph is going to be positive 5, positive 2, right? Because we have a minus in the formula here, but a plus in the formula here. So we switch the sign inside the absolute value, but we keep it like this on the outside. So let's put a dot here at 5, 2. And then we look at the slope next. We look to see if it's open up or down. And this A value on the outside is 1. So we know that it's positive, which means it opens upward. And the A value being 1 means there's a slope of 1. So if we start at this dot, we're going to go up 1 over 1 to the right like we would normally do. But since this is the vertex, we're also going to go up 1, left 1, up 1, left 1, and keep going like that. And then we can connect our line, and you see the V shape that's formed by the absolute value. All right? Really, really simple stuff here. So this second one, we have to find the vertex first, and we see we've got x plus 2, so we know the x value of the vertex is negative 2, so we switch that sign. We don't have a plus k, so that means that our y coordinate of the vertex is 0, so we can go ahead and plot that vertex. And we look at our A value. Our A value is positive, so this is going to open upward. But our A value is also 3 halves, so the slope of this as it opens upward is 3 halves. So we're going to start at this dot and go up 3, right 2, right? Rise over run 3 halves, up 3, right 2. And we're going to start at the dot and go up 3, left 2, up 3, left 2. And that will give us the points we need for that absolute value. Okay? And finally, example here, y equals negative absolute value of x minus 4 minus 1. Again, figure out your vertex point. It's going to be positive 4, negative 1 because of the signs of those x and y coordinates. So we'll go over to 4, negative 1. And we look at our A value. Our A value is negative 1, so this opens downward. So starting here, we'll go down 1, right 1, down 1, right 1, down 1, right 1, and down 1, left 1, down 1, left 1, and so on and so forth, so that we can connect our dots together and get that absolute value graph. We are going to use absolute values more the next section of stuff that we do. We're going to be graphing absolute value inequalities, and we are also just going to be putting these absolute value equations and functions into the use with the rest of our different kinds of functions that we've learned about to make some interesting systems that we can see. So down here, other thing that we're going to do today is solving and graphing inequalities. This is mostly to remind you how to do this. You've definitely done this before. So here are some tips on inequalities because you might have forgotten. The main one is when you multiply or divide by a negative number, you have to flip the inequality symbol. You have to make sure that it goes the opposite direction because multiplying or dividing by a negative is going to reverse the order of that inequality. The next thing we need to remember are the graphing rules. So we need to use a dotted line on our graph if we have a less than or a greater than, because those symbols mean we're not including the boundary line, but a solid line for a less than or equal to and a greater than or equal to, because those symbols mean that we are including the points on the boundary line as solutions to our inequality. And then finally, this is the one where we have to shade our lines. So we are going to shade above the line for greater than and greater than or equal to, makes sense with above, greater than, and below the line then for less than and less than or equal to. All right, so here are a couple. I like to change them into y equals mx plus b or into slope-intercept form before I graph them, but there are ways to go from standard form like this, and that's fine. So I'm going to say subtract x from each side. I get negative 2y is greater than negative x minus 4. And then I'm going to divide both sides by negative 2, which means that I have to switch my inequality symbol. So y is less than negative 1 over negative 2, that's 1/2 x. Negative 4 over negative 2 is plus 2. So we go in here and we put our y-intercept and we go our slope of 1/2, so up 1 over 2, up 1 over 2. And then we check to see what kind of line we need to make. We have a less than, so we need a dotted line because there's no or equals to. So we'll make that dotted line. And it is a less than, so we need to shade below the line. So we can just take it. It doesn't need to be perfect. Just shade in the area below the line. That way we know which part of the graph your solutions lie in. And that's all there is to it. I bet you remember doing a lot of these last year. So this other one, we want this to be in slope-intercept form, so we'll subtract 4x from each side, and we get y is greater than or equal to negative 4x plus 6. And once again, we're going to start at our y-intercept of 6, move that slope of 4 so we can put some points in here, and then check to see if it's a solid or a dotted line. This one's a solid line, so we'll put that solid line in there. And it says shade greater than or equal to, so we're going to shade above. One of the things that I get confused about, I don't know why I get confused about it, is what side of the line is above sometimes. And so if I'm confused about it, I imagine myself tying a little helium balloon to this line, and whichever way the helium balloon is going to naturally float, that's the above side. And sometimes that helps me just being directionally challenged like I am. So that's the side we're going to shade. All right. And believe it or not, that is all we are doing today. So using this information, you can go ahead and do the worksheet for section 3. Have a great day.